Given that one of the roots is an integer, solve the equation 6x cubed minus 29x squared plus 36x minus 9 equals 0. I'm going to call this cubic polynomial f of x. I'm going to call the integer root k. Since k is a root, that means that f of k must equal 0. Notice that we can write this cubic equation in this form here. I just shifted minus 9 over to the right hand side and factorized k out of these three terms. So what does this tell us? K is an integer. I'm saying that k is the integer root. We have an integer k multiplied by this thing here, but this is also an integer. So we have an integer multiplied by an integer giving 9. So that's something to keep in mind. It tells us that k must be a factor of 9. So we're looking for roots of this equation here. And now we know that one of those roots is a factor of 9. One of those roots is an integer, which is also a factor of 9. So that means that k could either be minus 3, minus 1, plus 1, plus 3. It could also be minus 9 or plus 9. Because all of these integers are factors of 9. They all divide evenly into 9. So we can test out each of these in our equation to see if we get 0. So in general, if we have an integer root of a polynomial, then we know that that integer root must divide the constant term. In other words, it must be a factor of this constant term. So k must be a factor of minus 9, which is the same thing as saying that k is a factor of plus 9. If it's a factor of minus 9, it's obviously a factor of plus 9. It turns out that f of 3 is equal to 0. So 3 is the integer root. So you can just try each of these in turn. And when you try x equals 3, you will find that this is 0. So by the factor theorem, if f of 3 equals 0, it means that x minus 3 is a factor of f of x. So to solve this equation, we need to get the other factor of f of x. So we need to divide f of x by x minus 3. Now I'm going to do this by synthetic division. If you look back to earlier videos, you'll see how to do it the more traditional way. So I've written out the coefficients of f of x here, and since 3 is a root, you write the root here. You write 6 down here. 3 6s are 18. You get minus 29 plus 18 is minus 11. Then you multiply 3 by minus 11 to get minus 33. 36 minus 33 is plus 3. 3 times 3 is 9. Minus 9 plus 9 is 0. So we expect to get 0 as a remainder. This is the remainder because x minus 3 is a factor of f of x. And the other factor is given by this here. It's going to be 6x squared minus 11x plus 3. So now we can write our cubic equation like this. The next step would normally be to factorize this thing here, assuming that it has factors. Putting this quadratic equation, or this quadratic factor, equal to 0 and solving, we end up getting x equals 3 over 2 or x equals 1/3. So the three solutions of the quadratic equation are x equals 3, x equals 3 over 2, and x equals 1 over 3. Two of the roots of the equation, ax cubed plus bx squared plus cx plus d equals 0, are p and minus p. Show that b times c equals a times d. So I'm calling this cubic equation f of x. Since p is a root, it means that if we calculate f of p, we get 0. So just replace x with p. Now we're given that minus p is also a root. So let's get f of minus p. So you just replace x with minus p. and it's a root, so we get 0. Now minus p all to the power of 3 is minus p cubed. Minus p all squared is just plus p squared. We get plus c by minus p is minus cp, then plus d equals 0. Now what we can do is we can combine this equation with this equation here. So we can add this equation onto this equation. So the ap cubed terms cancel out. We bp squared plus bp squared, that's 2bp squared. The cp terms cancel out. Plus d is plus 2d. We get 0 plus 0 is 0. Now what we have here is p, but we have p in terms of d and b, and we don't actually want p. Well, what we want is a relationship between b, c, a, and d, and to do that, what we can do is combine the same two equations again, but in a different way. Instead of adding them together as I did to arrive at this result, what you can do is take this equation here and subtract this equation. So you will get ap cubed minus ap cubed. That's ap cubed plus ap cubed, which is 2ap cubed. Then if you take bp squared plus bp squared, well, we want to take this term and actually subtract it, not add it. That will give us 0. They'll cancel out. If we take cp and subtract minus cp, we'll get cp plus cp is 2cp. If we take d and subtract d, we get 0. And if we take 0 and subtract 0, we just get 0. Now, we can simplify this a little bit. We can divide it all by 2 times p. We get ap squared plus c equals 0, and if we solve for p squared, we get p squared equals minus c over a. Now we can compare it to this result from the previous part. If I just square both sides of this, I should have left this as p squared. But anyway, if I square both sides of this, we get p squared equals minus d over b. So that tells us that minus c over a must equal minus d over b. So we just cross multiply and we get the result that we want. bc equals ad. Given that x minus c plus 1 is a factor of x squared minus 5x plus 5cx minus 6b squared, express c in terms of b. So c is a constant here, and so is b. Now we apply the factor theorem here. If x minus c plus 1 is a factor, that means that x equals c minus 1 is a root of f of x equals 0. So how do I find this root? Well, I just put the factor equal to 0. And I solve for x. I just bring minus c plus 1 over. So basically I'm just changing the sign of this part. So I just work out f of c minus 1, and I know that f of c minus 1 is going to be 0, because c minus 1 is a root of f of x equals 0. Now we expand this out, so we get c squared minus 2c plus 1, multiply minus 5 into this to get minus 5c plus 5, then we have 5c times c minus 1, that's 5c squared minus 5c, and finally we have minus 6b squared, and this all has to work out to 0. So we have to solve this equation to find out, or to get c in terms of b. So simplifying this down, we have c squared plus 5c squared is 6c squared. We have minus 2c minus 5c minus 5c, that's minus 12c. And then we have plus 1 plus 5 is plus 6. And then we have minus 6b squared. Now we can simplify this a little bit by dividing it all by 6. Now, how are we going to get c in terms of b? You see, we have a c squared term here and a c term, so how do we isolate c? Well, we should look at this quadratic expression in c. It turns out that we can factorize this thing into c minus 1 times c minus 1, so we can write this as c minus 1 squared. C minus 1 squared is c squared minus 2c plus 1. C minus 1 squared is b squared, so to get c minus 1 we get the square root of b squared. And there are two values to that. It's either plus b or minus b. So if c minus 1 equals plus b, we get c equals b plus 1. If c minus 1 equals minus b, we get c equals minus b plus 1. So there are two expressions connecting c and b, or two equations connecting c and b. Now here I've done a check for one particular value of b. Of course b can be any value, but I'm just checking it for b equals 1, and I'm using this form here. If b equals 1, it means that c equals 1 plus 1, which is 2. So that means that our factor x minus c plus 1 will become x minus 2 plus 1. That's x minus 1. So this will be our factor. And what we do here is plug 2 in for c and 1 in for b. When we plug 2 in for c, we get 10x here. That's this term. When we plug 1 in for b, we get minus 6 here. Simplify this down to get x squared plus 5x minus 6. We hope that x minus 1 is a factor of this, and it is. If we multiply x minus 1 by x plus 6, we will indeed get this, showing that x minus 1 is a factor. It divides evenly into this. Now if we use the other form, c equals minus b plus 1, I'm still using b equals 1. It's just one value out of an infinity of values, but let's just see it work. If we plug 1 in for b, we get c equals minus 1 plus 1, which is 0. So that means our factor x minus c plus 1 is going to be x minus 0 plus 1, or just x plus 1. And what we're dividing into is going to be x squared minus 5x plus 5 times 0 times x. C is 0. That's going to give 0. And b is 1, so we're going to get minus 6 times 1, or minus 6. So hopefully x plus 1 is a factor of this, and it is. If we take x plus 1 and multiply by x minus 6, we will indeed get this. So both of these equations for c work when b is 1, and they also work for all values of b. X squared minus t is a factor of x cubed minus px squared minus qx plus r. Show that p times q equals r. Here is one approach. I'm going to call this cubic f of x. Now, x squared minus t can be factorized into x minus root t times x plus root t. So we're interested in linear factors of f of x. That is, factors that have x to the power of 1 in them. This is a quadratic factor of f of x. So we can think of this thing as x squared minus the square root of t squared. We see that it's a difference of two squares, so we can factorize it into x minus root t times x plus root t. Now, since x squared minus t is a factor of f of x, it must be the case that x minus root t is a factor of f of x, because x minus root t is a factor of x squared minus t, and x squared minus t is a factor of f of x, so this has to be true. We could apply the factor theorem now. If we know that x minus root t is a factor, then we know that f of root t must equal 0. So I'm just going to get f of root t. So we plug root t in for x, and we get root t cubed minus p times root t squared. Now root t squared is just t, so we get minus p times t. Then we have minus q times root t plus r, and this must work out to 0, because root t is a solution of the equation f of x equals 0. Similarly, we can use the fact that x plus root t is also a factor of f of x, because it's a factor of x squared minus t. If x plus root t is a factor, then we use the factor theorem, which states that f of minus root t will be 0. So we plug minus root t in for x. Now minus root t cubed is minus root t times minus root t times minus root t, so we'll get a minus sign back. It's just like taking this thing here and cubing and minusing your result. Then we've minus root t squared. Well, that's going to give plus t. Minus q times minus root t is plus q root t, and then we have plus r equals 0. Now if we add these two equations together, we find that these terms cancel out, and so do these. Minus pt is minus 2pt, r plus r is 2r equals 0. We can rearrange this to get t in terms of r and p. We get t equals r over p. We just take minus 2r and divide it by minus 2p. We get plus r over p. Now, if we plug this thing into the top equation here. Now, I've just replaced this t here with r over p. That's what we have here. And these p's cancel, so we get minus r here, and we get plus r here. So all of this cancels with this. And we're left with root t cubed minus q root t equals 0. So I didn't plug in for t here, but you see we can actually find out what q is. Well, q in terms of t anyway. Minus q root t equals minus root t cubed. And we change the signs here, so we have q. Root t cubed divided by root t is root t squared. But root t squared is just t. So we see that q is actually equal to t. So we can go back to this and replace t with q. So we get q equals r over p, from which we get r equals pq. That's what we have to show. In part 2, we want to express the roots of x cubed minus px squared minus qx plus r equals 0 in terms of p and q. Now we know that x squared minus t is a factor of this, and we know that t is equal to q. So that means that x squared minus q is a factor of this cubic. I've also replaced r with pq. So if I divide x squared minus q into this, I have to get a remainder of 0, since x squared minus q is a factor. So you begin by dividing x squared into x cubed to get x. Then you multiply x by x squared to get back x cubed. X times minus q is minus qx, so you have to write minus qx in under this term. The next step is to subtract. When we subtract, we get 0 here. We have minus px squared minus 0 is minus px squared. Minus qx plus qx gives us 0. And after subtracting, we take down the next term, which is plus pq. Now we go back to dividing. We divide x squared into this term to get minus p. Multiply minus p by x squared gives minus px squared. Minus p by minus q is plus pq. Then we subtract and we get 0 as expected. This is our remainder. It has to be 0 because x squared minus q is a factor of this cubic. So we can write our cubic expression as the product of x squared minus q and x minus p. And we're interested in the roots of this. So we've put it equal to 0. We solve this equation. So we have the product of these factors giving 0. So we put each factor in turn equal to 0. So if we put x squared minus q equal to 0, we get x equals plus root q or minus root q. Now we saw these already, but we had them in the form root t or minus root t, but t is equal to q. So we've seen these. Now we get another root by taking this factor and putting it equal to 0. So it leads to another root, which is x equals p. So that's our new root. So here are our three roots. X equals plus root q, x equals minus root q, and x equals p. So we have our three roots in terms of p and q.